السلام عليكم ورحمة الله وبركاته. يعطيكم العافية شباب وصبايا. Our video for today is from chapter 17, which is about resistance and resistivity only, because we need these two parameters in chapter 18, which is about the nerve system. Now, in general, let we assume we have a wire, as you can see here, cylindrical wire of length L and cross-sectional area of A in meter squared. And we have a current of magnitude I in unit of ampere or A passing through this wire. Now, in general, the current encounters a resistance to its motion as it flows through this wire. Therefore, we can define the resistance as the voltage or the potential difference across the wire divided by the current. Now, from here, it's obvious the unit of the resistance is volt divided by ampere, or we can call it 1 ohm. First example, I have a wire of potential difference 10 volt, and the current passing through this wire is 4 ampere. What is the resistance? As we've seen from the previous slide, the resistance equals the voltage or the potential difference divided by the current, which is 10 divided by 4 will give us 2.5 ohms. Now, the electrical resistance is depends on the size and the geometry of the wire. As you can see here from this relationship, the resistance is inversely proportional to the area, which means larger cross-sectional area permits current to flow more easily. As I increase the area, the resistance will decrease. Now, from this, the second relationship, we can see the resistance is directly proportional to the length, which means larger length or long wire presents more resistance than short wire. As I mentioned in the previous slide, the resistance depends on the geometry and the size of the wire. In addition, there is one more thing. The material from which a wire is made also affects the resistance of the wire. As you can see here as an example, current flows easily through conductors and only with difficulty through the insulator. Therefore, we can say the resistivity, or we have a new parameter, which is called the resistivity, whereas the resistivity is the quantitative measure of the material opposition to the flow of the current. In other words, we can say the resistivity depends only on the chemical composition of the material under a constant temperature. And we can say the resistivity, or rho, equals to R times A divided by L, where the resistivity from this has a unit of ohms times meter. There is another quantity or parameter, which is the conductivity, which is 1 divided by rho. Third or second example, a nerve fiber may be approximated as a long cylinder. If its radius is 1 micrometer and the resistivity is given, what is the resistance of 0.314 meter long of this fiber? Okay, we know the resistivity is given by R times A divided by L. Therefore, the resistance from here are equal to rho times L divided by A, whereas rho is given, L is given, but the radius is not given. Since we know the radius, we can say the area is by R squared, and be careful here, the radius in micrometer, so you have to convert it into meter, which means multiply this by 10 to the minus 6 in meter. You will get by the end 0.2 times 10 to the power 12 ohms. The last example, which is about a long copper of length 2 meter has a resistance of 0.01 ohms and radius of 0.001 meter. What is the copper resistivity and conductivity? Okay, we know the resistivity is given by R times A divided by L. We know, or we have the resistance, we have the length, but the area, or actually the cross-sectional area, is unknown. Go back to the question, you will see this hint, which is about the radius. Since we have the radius and we are talking about cross-sectional area, we can say the area is by R squared, and plug the amount of, or the values of each numbers, you will get the resistivity equals 1.73 times 10 to the minus 8 ohm times meter. Thank you, and see you next time.